this video, I'll go through the Unit 1 review sheet very quickly. First off, which is the largest standard deviation? You might be tempted here to go ahead and pick the largest number, but here, we need to pay attention. Units aren't given to us, so we actually cannot determine. So for example, just because 1,000 is the biggest number doesn't mean it's the largest standard deviation. For example, this could be millimeters versus up here this could be miles. So then all of a sudden 15 miles is obviously a much bigger spread than 1,000 millimeters. Number two, which of the following data sets has a mean that is above the median? So remember, the mean is not resistant, which means it can be affected by outliers, which here we got some really big outliers. So for number two, the correct answer is B. This is a quick heads up, both A and D right there, they're both symmetrical, which means the mean and the median are going to be very, very close to each other. And then here, because this is skewed to the left in part C, the mean is actually going to get pulled down toward the tail. So remember, the mean and the skewness both follow the tail. Number three, I'm going to come back to it here at the end of the video. Move instead right here to number four very quickly. So which of the following would best be represented by a bar graph? And here, that just means we're looking for categorical data. And I can definitely see the argument for A. However, you can do average earnings, you can do average heights of waves, you can do average SAT scores, but the one that doesn't make any sense, that definitely puts you into a group, would be favorite number. So there's a group of students with this is a favorite number, a group of students with that is a favorite number. Using the 5-number summary, let's take a look at this. So what percent were between 125 and 160? So this would be the minimum up to 160, which is Q3. Well, that would represent 75% of the data. Are there outliers? So for part B, we need to do Q3 minus Q1. Let's go and get that IQR, which would be 160 minus 130, which is 30. 1.5 times 30 puts us at 45. And then if we go Q1 minus 45, 130 minus 45 would put us at 85. And then Q3 plus 45 puts us at 205. So there's nothing below that, and although 205 is right there with it, it is not above it, so there are no outliers. Even though the bound is the maximum, it's not beyond the upper bound, so no outliers. C, the mean, it looks like is above the median. Just like we saw before, what's going to pull the mean up? That would tell us, again, right, for the mean to get pulled up, we need a skewed right data set. It tells us the data set is skewed right. And then finally for D, how many observations are in this data set? Well, all we know are 5 particular numbers, so we actually cannot determine. There's an argument you can make that we know there's at least 5, but even that we're not quite sure of. So cannot determine, probably your best bet there. Number 6, so the science class has collected this data, and so what we need to do at this point, we're going to do some quick calculations on this. So the mean right now equals 25 centimeters, standard deviation equals 3 centimeters. Well, they realized all of a sudden that they've measured everything 2 centimeters too long. So the new mean, well, we'll just subtract 2 centimeters. And then the new standard deviation, well, here's the thing. If everything slid down 2, then we're still at 3 centimeters. All right, so we've got a new mean and new standard deviation after we accounted for this Canadian ruler. And we also need to go ahead and make the conversion into inches. So we need to convert. And just as a heads up there, 2.54 centimeters in 1 inch. So in order to make this conversion, we need to just go ahead and divide through by 2.54. And so if we go ahead and do the 23 divided by 2.54, we end up that we are at 9.05 inches, and 3 divided by 2.54, and 1.18 inches. So There's my mean. There's my new standard deviation. Number 7. The following graph is constructed. Here's these 40 pieces of data. First period, I'm sorry I used a different graph. I went back and put this one in. Find Q1 and Q3. Well, since there's 40 pieces of data, we basically just need Q1 is going to be somewhere around the 10th. Q3 is going to be somewhere around the 30th. So as we can see, it looks like there's 2 pieces of data there, and then there's another 11 here. So far there's a total of 13 pieces of data, which means somewhere in there is the 10th data point in this particular bin right there. So Q1 is in this bin. And then I'm actually going to work my way back from the beginning. So again, 2 there. It looks like this is about 7. So we're up to 9, which means that the 10th data point back should be, right? So there's 9. We need to go 10 back, which puts us in the gray bin. And again, we needed to go 10 forward. So describe that particular graph. Well, it looks like it's bimodal. I would say there's a slight skew if I kind of erase all my stuff here. Looks like there's a little bit of a skew tailing off. Slight skew to the right. No apparent outliers. Again, without actually crunching the numbers, I probably shouldn't say there are no, but no apparent outliers gives me a pretty strong statement with the flexibility to come back. Maybe we're centered around a score of 500. Right? And then all of a sudden that score of, that's our context, right? That's important. And then also looks like spread, we're going anywhere from the range. And again, we don't know the exact values, but we do know we're going from, if we look closely, we do see we're going, the upper part of this bin is going to be 650 all the way down to 350. So range, we don't know that there is a particular score of 650 or is a score of 350, but we could say the range is approximately 300 points. Right, so again, we're keeping context involved. Make sure we're doing that tomorrow when you sit down to take this test, or especially, I guess, on Wednesday. Here's an ogive. We can see that there are 150 students, so n equals 150, and that could come into play. So what percent of students consumed at least 10 ounces per week? So if we go up to 10 ounces, we go over, that's the 60th percentile, so at least 10. So we need greater than or equal to 10 ounces. Well, that's everything from here on up, which would account for 40% of the folks. So we need 40% out of the 150. And so that tells us that there's about 60 students. For part B, what alcohol consumption is associated with Q1? Well, think about this. Q1, that's really like saying the 25th percentile, right? So let's go to 25th percentile, then go down. So maybe approximately 4 or 4.5 ounces. And then about what percentage of students consume between 4 and 8 ounces? So 4 gives us the 20%, 8 gets us up to 60, so that's 40%. Let's make sure we don't need something different. It just says about what percent, so for C, about 40%. Number 10, we match these things up here with the very first one. All the numbers should be the same. For the second one, we need a unique number for minimum, Q1, median, Q3, and max, which would go hand in hand with A. We look at, we got C, we got A taken care of. Here, for the third one down, we need the quartile 1, the median, and Q3 to all be the same, which would correspond to D. And again, that leaves us with B, but as you can see, the minimum and the Q1 and the max and the Q3 are the same number. So there's your answers for the box plots. And then matching the histograms with the appropriate. Here we get this left skew, look like there's some outliers. That's a pretty easy match to D. Now it's just reminding ourselves, the big box doesn't mean more data. That means it's more spread, right? tells us the data is more spread out, right? Same thing. Big whisker doesn't mean there's more data out there. It just means that there's more spread. So make sure that we're paying attention to that. So one way to think about this when we're looking at B, and again, little whisker means the data is pretty, maybe you think about it this way, it's concentrated on the ends. And you start thinking about it in terms of that, we realize this particular one down here goes with B. The data, where there's kind of more data concentrated in the middle, and then looking at C right here, we got a bigger spread as we move out. Well, that'd be sitting right here, excuse me, with kind of this bell-shaped curve. And then here, if you look at A, this is very uniform. It looks like 25% in each one of those bins. So it's very uniformly distributed. So there's that particular answer. All right, so back to 3 very quickly. Which scenario would produce a median greater than the mean? So in other words, we want the mean to be less. So we want an outlier. We want the mean down here, the median here. This really isn't the best question, so I will warn you. It's not going to be one kind of this strangely this abstract, if you will. The ideas will be a lot simpler to kind of think about. You're not going to have to know your history like the stock prices. But one thing to think about, so if you think about a dot plot depicting the heights of individuals in an elementary school, that's going to be a lot of short people, and then maybe a few tall people that are the teachers. So that's definitely not going to do it. That's going to give us a mean that's greater. If you have a really tough test, right, you think about a tough test, you'd have a lot of low scores and a few high scores. So B is definitely out. The salaries are for a professional sports team. I could go back and forth between A and C. Again, on the test, it's going to be a lot easier to see. One way to think about it, most of the people on a professional sports team make a lot of money, and there's probably a couple that make a little bit, and then a few that make a lot less, so maybe that's more skewed toward the left, where there's a big group of people, maybe kind of toward the lower end of the salary. Stock price, you think about from 1920 until about 1930, they went up and then they plummeted, if you want to look at them that way. That's maybe where I was going, but you could also make an argument on that professional sports team, maybe you have a lot of, not a lot of people here, then you get some big salaries. And although there's a few people that make a whole lot of money down here, again, 3, not really the best question, so you can kind of throw it out. The scenarios will be a lot easier to interpret and understand tomorrow as you take your test.